Hello everybody. In today's lesson, what are we going to be talking about is using properties of logarithms to either condense or expand a logarithm. Particularly what we're going to be doing today in this lesson is how do you condense a logarithm. Now this again follows along with the idea that because logs are inverses of exponents, a lot of the things that I could do with exponents, I can do with logs as well. And one of the properties that we practiced, particularly as an Algebra 1 student and as an Algebra 2 student, is how do you use those properties of exponents to simplify, either condensing something or expanding something. How do you use them? Well, with logs, they're pretty similar. When we had exponents where the bases were the same and we were multiplying them, all we did was wind up adding the exponents. And it's kind of exactly what you see here with logarithms. What we would see on the right side of the screen, this is the uncondensed logarithm, and on the left side is the condensed form. And what we're going to do is we're going to take stuff that looks like it is on the right hand side of the screen and condense it to where it looks more like the stuff on the left hand side of the screen. So because the bases are the same and you're adding the logarithms together, well, we can put whatever the terms in the parentheses are together in one parenthesis and multiply those together. And depending on whether they're numbers or expressions, really doesn't change the fact that we wind up multiplying them. We just multiply them, except if it's an expression, we'll say, we'll have x with something in there or some variable, and if they're just numbers, we'll just multiply the numbers together and see what we get. And the one on the bottom here, again, the stuff on the right-hand side is the uncondensed logarithm, and what we'll do is, just like with exponents, when we divided powers to the same base, we wound up subtracting the exponents from each other. And with logarithms, it's kind of what we're looking at here. If we're dividing two terms that share the same base in the logarithm, well, we can separate them and show that we can say log of that base minus log of the other thing, and write it like that. But again, primarily what we're going to be doing today is taking it in uncondensed form and kind of rolling it up and packaging it together in a condensed form. And the whole purpose of this particular skill isn't so much about practicing just condensing something or uncondensing something or unrolling it, so to speak. The reason why we need this skill is because we'll use it when we have logarithms, equations with logarithms that are a little bit more complicated, because the equations that you've seen so far in your instruction have been an equation where we had a log, where it said log of something. Maybe we might say plus this or minus that or multiplied with it or something, but it's only just one log in the equation. Well, we could have equations where we have more than one log, and as a result we need to know how to use these properties of condensing or expanding in order to solve an equation like that. And again, the stuff on the right side of the screen, this is kind of the uncondensed logarithms, and the ones on the right are the condensed, the ones on the left are the condensed logarithms. And what we'll be doing is kind of taking the uncondensed stuff and condensing it in this lesson. Now, the first thing that you're seeing here where it says replace any coefficients as powers, that's kind of like that power rule that you just saw. For instance, if you see like 2 log base 3 of x, where it says to replace any exponent or coefficients, well, the 2, that is the coefficient that they would be referring to, and to write it as a power, we would say log of whatever the base is, in this case 3, x to the second power, like that. That's kind of what problem or statement 1 is telling us. Statement number 2 is saying, well, okay, if we have to combine, if our logs are being added together, well, we wind up multiplying things together, and maybe it's just two simple numbers, maybe it's two expressions. So if we have like one log that says, for instance, maybe I have log of x plus 1, and I'm adding log of x minus 1. Well, when we rewrite those in a condensed form, I would have log of x plus 1 times x minus 1. So that's what it means when it says, well, maybe we might have to FOIL something, but we're just taking whatever is inside of the exponents, or I'm sorry, inside of the parentheses of the logs and multiplying them together. And it'll be the same thing if we subtract them. We would kind of divide whatever we might have together as common bases. So again, just as a quick kind of example, if I say log of, I don't know, x plus 4 minus log of, I don't know, let's say x. It could just be that simple. All we're going to do is we would take whatever the parentheses are, and I would write it as log of x plus 4 over 2. And if we could simplify anything from the top and the bottom, we would. Okay, let's go ahead and see how we're going to put these together. So here, the first thing that we see is we have two logs that are the same base. They're natural logs, so the base is e. And I have the natural log of x minus 3 plus 2 times the natural log of 3x. So this 2 is what we would think of as the coefficient. So the power rule says we're going to take that and put it in the exponent position here. And we will do that first, pretty much because that's what the order of operations would make us do anyway. So when we go to our next level here, the natural log of x minus 3 plus, pardon me, we'd say the natural log of 3x squared. Now we can actually square the numbers inside of that parenthesis. So I would say the natural log of x minus 3 plus, and if I square the 3 inside of the parentheses, I get a 9. And if I square the x, well, we don't know what x squared is, or x is, so we just say x squared. So now we no longer have any coefficients or exponents, and we're adding logs that have the same base. So that means we're going to take those and multiply them together. Now, at this point, I'm going to write this two ways. I'm going to say the natural log of the first parenthesis, which is x minus 3, times the other log, which is 9x squared. I can write it like that, or I could write it as the natural log of, let me put a bracket here because I have more than one parenthesis, 9x squared times the x minus 3. The order in which I write the numbers or the terms that I'm multiplying doesn't matter, but I know from experience that most students are accustomed to multiplying left to right. So we would think of the 9x squared being distributed in here, but we can also distribute it from right to left just as easily as we would from left to right. But, pardon me, either way, when we do it, 9x squared times the x is going to give me a 9x cubed, and a 9x squared times the negative 3 will give me a negative 27x squared. And this would be our final condensed logarithm. So again, using the rules that we saw, we started by taking the coefficient, putting it into the exponent spot of its log, and we actually squared the numbers that were inside of it. in order to just have log of this base and log of this base. Because the bases were the same, and we're adding the two logs together, that tells you to multiply whatever was in one parenthesis to whatever was in the other parenthesis. Okay, so here is a relatively straightforward problem. The reason why I say it's straightforward is because unlike the first example, we don't have any coefficients in front of the logs. I mean, we do, it's a 1, but multiplying by 1 doesn't change anything. So we don't really have any coefficients to worry about that are in front of the logs. And the bases are the same. We have a log of 3 on the left and a log of 3 on the right. So there's no exponents that we have to worry about like we saw in the first example. So what this is telling us to do, because we have bases are the same and we're subtracting from each other, we can put these together as saying log base 3, and we can put these in one set of parentheses, and in the numerator will be the whatever we had on the left. So I'll have 3x squared plus 5x as the numerator, and whatever the log on the right is, the one that we're subtracting with, that goes in the denominator. So I would just have the x there. So the only thing that we would do at this point is we need to look at the fraction and see, can we simplify the fraction at all? Now in the numerator, we see that they do have a common term that can be factored out. In the numerator, there is an x in both the 3x squared and the 5x. So I can factor out an x from both terms in the numerator. So now in the numerator I have one term, which is the x, multiplied to another expression, the 3x plus 5. So because the x is being multiplied to something in the numerator, and I'm also dividing with the x, well, the x in the numerator and the x in the denominator, they just simplify to be 1. And because they simplify to be 1, multiplying or dividing by 1 doesn't change anything. So the final simplified expression will be log base 3 of 3x plus 5. Now, the last example that we're going to look at, again, fairly straightforward, no trickery or chicanery involved. The coefficients of both logs is just 1, so we don't have to do anything with the exponents. The bases are the same, so because we're subtracting logs with common bases, I'm going to say log base 5, and I'm going to take whatever is on the left of the subtraction operation, and I'm going to put that in the numerator, so x minus 7 goes in the numerator, and the x plus 4, oops, plus 4, not x4. So the x plus 4, because that is the one that's being subtracted from the first one, that goes to the denominator. And now we see, okay, well, can we simplify the fraction? Is there, kind of like on the last one, is there something I could factor out of the numerator or the denominator to therefore see if I can simplify it any further? And the answer is no. There's nothing in the numerator that is like a common thing that I can pull out, or same thing in the denominator. And because it's an expression x minus 7 over another expression x plus 4, the x's in the top and the bottom are being added to something else. So I cannot simplify anything top to bottom until I actually perform those operations, the adding or subtracting. So that is it for that one, guys. There's nothing else to simplify, and so we just leave it like so. And all of the other expressions that you're going to be performing in your assignment are very similar to these. There's just more of them. They're trying to just give you different numbers, different bases, and different combinations of it, see how you do. So if you have any questions about anything that you've seen in this video, please make sure that you write your questions down into your notes and bring them to me when you come see me in class. Until then, guys, we're done with this lesson. So thanks for watching, and have a good one.